Now that we've talked about solving some systems of equations using one of these augmented matrices, let's really try and nail down the form that we're trying to get these things in. Right? So remember, when we're doing systems of equations, when we're solving them like as systems of equations, I talked about this particular way we want to do it, where we try to get like the x first and then get rid of all the x's below it. Then we move down an equation and try and get the y by itself, and then get rid of all the y's below it, and so on, right? So how does this apply here? How does this apply to matrices? Well, this is putting it into what's called row-echelon form. When you put it in that form, you set yourself up to do this back substitution. Okay? So the first step in row-echelon form is, or I should say, there's three things that must be satisfied to put something in row-echelon form. Right? The first thing that has to be satisfied is any rows that consist of all zeros, just shove them to the bottom. Right? That's the first rule. The second rule, now here's where we start getting into a little bit of terminology. If we look at a row, the very first number we see in that row, assuming we have a row that's not entirely made up of zeros, the very first number we see in that row that is not a zero needs to be a 1. Okay? That should always be the case. So whatever the first non-zero number is we encounter in a row needs to be a 1. The third thing that has to be met in order to be in row-echelon form, the one that's maybe a little bit trickier to think about. If we have two successive non-zero rows, so two rows, one on top of the other, that are not made up of all zeros, then this leading one, right, that's the thing we talked about in the last step, the leading ones, the one for the top row has to be further to the left than the one in the lower row. So what this means is, if you imagine kind of making a staircase out of your leading ones, the staircase should go down and to the right the whole time, right? So you should never have a step that's like 2 rows high. You can have a step that's 2 columns wide, but you can't have a step that's 2 rows high. And you should never have steps going to the left. They should constantly be going down and to the right. So that's what the third one. Okay. So we'll look at some examples in a bit, but I wanted to add in a fourth thing real quick. So what we talked about there was row-echelon form. Right? This is what sets us up for that back substitution stuff. Right? Now you might remember we did an example of solving a system of equations where not only did we get zeros below variables, but we also got zeros above. That's what we call reduced row-echelon form in a matrix. So here is the fourth criteria. In order to be in reduced row-echelon form, there's one additional thing that has to be true. Right? Every column that has a leading 1 in it, which, if you read the 3 requirements above, there's no reason that every single column must have a leading 1. Right? Every non-zero row should have 1, but not every column. And this is what I was saying about steps being 2 columns wide. Right? But any column that does have a leading 1, everything else in that column needs to be a 0. Right? So this is trying to make this basically is when we solved the system of equations and we got one that was just x equals this, y equals this, z equals this. We're trying to do that in the matrix form, right? And this is like the full conclusion to the algorithm. Okay. So that was a lot of words about this stuff. So I encourage you to, pause the video if you need to, read through these definitions, look at your notes on them, and think about them for a bit. And then we're going to move on to some examples here. Right? So I have a bunch of matrices here, and none of these are in reduced row echelon form. Some of these might be in row echelon form, but none of them are in reduced row echelon. Okay? What I want to do is first off identify if it's in row echelon form or not, and then, if regardless, say what we need to do to put it in reduced row echelon. So this first one here, the top left, what's wrong with this one? Well, if we look at this first row, this is a leading 1 right here. It's the first thing we encountered in that row, and it's a 1. So that's fine. But if we go to the second row, the leading 1 is to the left. Now again, the leading 1 should form a pattern kind of moving down and to the right. Here it's going down and to the left. Isn't what we want. So basically here, all we need to do to fix this and put it in reduced row echelon form is swap rows 2 and 3. Right? If we do that, then we get the reduced row echelon form. I was trying to fit this all in one page. Here, like, work. Page complete. Okay. Anyway, so let's go ahead and rewrite this matrix here. 1, 0, 3, 0, 1. Right? And if we look at this, now this does satisfy all of those requirements for reduced row echelon. And again, well, this has this pattern for the 1s that's going down and to the right. Right? Let's look at this one here. The second one, is this in row echelon form? Well, it is. This is in row echelon. But it's not in reduced row echelon. Why is it not in reduced row echelon? Well, here's our leading 1. This is good. Your first row should actually always have a leading 1 in the top left corner. So this is great. However, when we go to the next row, so if we move down a row over a column, this is a 0 and there's no other rows to switch with it, so this 0 is fine. We just move over an extra row, and here's our next leftmost 1. So this has this down and to the right staircase pattern I keep talking about. And again, here's a 2 column wide step, so this is perfectly fine. When it comes to reduced row echelon form, the issue we have is this thing. this needs to be 0, right? Because again, any column that has a leading 1 in it, everything else in the column needs to be 0. So how do we fix this? Well, we do row 1 plus 2 row 2, row 1. Right? We do that, we have 1, 2, 0, 1, 0, 0, 1, minus 1. There you go. Now this is in reduced row echelon form. Here's the leading 1. Everything else in that column is 0. Okay. How about this one? What's wrong here? Is this in row echelon form? Well, it's not. This column, or this row right here, sorry, this is a row of all zeros. A row of all zeros needs to get pushed to the bottom. So all we have to do here is just swap row 2, row 3. We do that, we get 1, 0, minus 3, 0, 1, minus 2, 0, 0, 0. Okay? And finally, let's look at this last one here. Oh, sorry, let me say real quick. This has this down right staircase pattern. Technically, this one does too, but remember I was saying that we should never have a step be 2 rows high. Right? We should never have a step be 2 rows high. Okay. But here is exactly what we're looking for. So basically, ideally, we're trying to fit our leading ones into that that main diagonal of the matrix. Okay? Sometimes it might extend further to the right of the main diagonal, but it should never, ever go to the left of it. Okay. This last matrix here, what's wrong with this one? Well, this is neither in row echelon nor reduced row echelon form. And the reason is this too. This needs B1. And how do we fix that? Well, we just take 1/2 of row 2, replace row 2 with it. Get 1, 0, 0, 1, 0, 1, 0, 3 halves, 0, 0, 1, 5. And there we go. And again, the leading ones form this staircase pattern. All right. So I'm gonna leave these to you to think about how you would fix them. But let's talk about or how you would put them in reduced row echelon form. Right? I want you to think about that. But let's talk about whether these are in row echelon form. This one isn't because of the 3. Okay, so here's the issue here. This one is in row echelon form. But it's not in reduced row echelon form because of this 5. Everything else is fine. These numbers, this column is fine. Just that 5. This here is in neither. These two are out of place. Think about how you can fix that. This one is also neither because of our row of all zeros. Okay? So try and make sense of, what's going on with each of these, why they're not in row echelon form, and how you can fix them. In the next video, we'll talk about a little more about solutions and sort of a procedure for getting this Gauss-Jordan, or sorry, this reduced row echelon form.